Welcome back guys. In the last video, we saw how to use Pandas library by Charm. Now in this video, we will see how to do pretty same thing from Jupyter Notebook. First, you should be having Anaconda 3 installed on your system. If you don't have Anaconda 3, install it. First, create a folder where you will save your Jupyter project. In my case, I will create it on Drive. I will name this folder as test. Now I will grab this test file. This is the same test file that I used in my last video. I will copy this and paste it in the test folder I created. That's it, we are good to go now. Now open Anaconda prompt, wait for a few seconds. First go to the directory where you created the folder and added your Excel file. In my case it is eDrive. If you are in your required folder, then type Jupyter Notebook and hit enter. Wait for a few seconds. Jupyter Notebook will be opened in your default browser. It will redirect to the folder that we created. There is nothing here except the Excel file. Click on New, select Python 3. It will create a new project. Here we can enter all our code. Enter matplotlib inline followed by a percentage symbol. The matplotlib inline will make your plot outputs appear and be stored within the notebook. Now I need to import Pandas and NumPy. Import Pandas as PD, then import NumPy as MD. That's it, we have imported the required libraries. diff equals p_read_csv, test_csv. So what's going on here is this is going to load up the test.csv. So with this one line of code, we can read that data from dest and create what's called a data frame out of it, at a pandas data frame, and we're gonna assign that data frame to a variable called the CSV file. That's a comma-separated values file. That just means that it's tabular information where each column is separated by a comma. So it's a very simple text-based format, and the first row usually corresponds to the titles of those columns. We don't need any print statement here. Directly data frame object can be printed. Head method will display a few rows only. So let's actually click in here and hit Shift Enter to run it. And you can see here this is a little preview of the file, so if you just want to double check that everything loaded incorrectly and understand what's in it. Remove the head method from data frame object and print only the data frame object, and it will print all the record. You can also pass in an integer to head if you want to see some specific number from the beginning of your file. So if I want to see the first 10 rows of my data frame, I could just state dataframe.head of 10 like that, and that will print the first 10 rows. You can see a little bit of a larger sampling of data there, and you can also look at the end of your data file as well here. Now let's do some manipulation of this data frame. Let's say we want to extract just a single column from that data frame. Let's say we just want to extract the product category column or customer segment and do something specifically with that. So if I say data frame bracket quote product category or bracket, if it will just extract the product. Often when you're loading in data, you're not interested in every single feature that's in it. You want to extract certain features that you care about for the model that you're building. This is how that would work. You can also extract more than one column if you want to. Obviously, that's going to be a more common situation. You would do that like this. So instead of passing in just a single quoted column name, you could pass in an array of column names. Instead like this, so we are gonna say data frame bracket, and then we're gonna have another layer of brackets inside those brackets that represents the array of column names that you want. So we're gonna say data frame bracket, order ID, product category, bracket. And that will give us back this new data frame here that consists the order ID and product category and nothing else. And obviously you can add more columns to that list if you want to, so you know, again, a very common operation to extract only the features or the columns that you actually care about for a specific task. The less data that you push around, the better, so that's usually the first thing you want to do, get rid of the stuff you don't care about. We can also do value counts. That's the way of breaking down how many of each unique value exists, which can be a useful way to visualize your data. First, we need a new data frame object. All you need to do is say df and then the name of the column that you want to count on .value counts, and that will give you a count of each unique value within there. So make it real. Say we want to create a value count series out of the product category column in our data frame, and then we'll go ahead and print that out by just saying df_new, and we get back this result. Let's use customer segment column instead of product category column. I have been using this product category column in my last video also. We get back this result, which indicates that in our entire data frame, there are 17 corporates, 5 home office, 2 consumer, and 1 small business. You can also extract a single value, like that if I were to say bracket 5 at the end, that's explicitly plucking out the customer segment column on the 5th row, which happens to be the value. You can also extract a given range of rows within a column like this. So if I do df customer segment, and then an additional bracket with column 5 that will extract the first 5 rows of the customer segment column, then I get back a new data frame that looks like that just 5 rows of the customer segment column, if nothing else. So if you want, the tempting thing to do here is to create a histogram. So if we want to plot that distribution, that's very easy in Pandas as well. We can just say df.plot bracket kind equal to bar. So saying we want a bar plot of this df_new, and since we used matplotlib in line way up the top, that just go ahead and displays within our Jupyter Notebook. So very easy to actually make graphs using Pandas as well. Alright, we can change the kind to pie or line to change the plot to line or bar chart. So very easy to actually make graphs using Pandas as well. Alright, we can change the kind to pie or line to change the plot to line or bar chart. This is very useful in situations where we need pie chart or histogram for the data. There's a lot more to Pandas than this obviously, but these are the most common operations that you need to deal with and pretty much everything you need to know. That's it for this video. We will meet in another video if my content is useful, and if you like my content, then don't forget to drop a like and subscribe.